Hey guys, how you doing? Let's do some more factor, label, stoichiometry. However, let's do mass volume. Okay, that means we have a mass that we're starting with, and we're looking for a volume at the end. So, for instance, just like before, we have 15 grams of zinc reacting in an excess of hydrochloric acid, HCl, and it's going to yield zinc chloride and hydrogen gas. The question will be is how many liters or what's the volume, it could ask, or volume or liters, it could say what's the volume, but how many liters of hydrogen will be produced. Okay, so that's the question. So we're saying, okay, we have this much of zinc, and we want to know how many liters or what's the volume of hydrogen being produced. Okay, so keep this in view. We've got this factor label going on. So basically, we have to first say, what is our known, K, and our unknown, U? So our known is 15 grams of zinc. We've got 15 grams of zinc. Our unknown in this scenario is the volume, or how many liters of hydrogen gas. Okay, that's our unknown. Don't know. Okay, that's an H2 right there. So over here, this is where I would put the GFW of the zinc first. So I need to know, I use my periodic table, I look up, now this is just a single atom, so you could just use your periodic table. So it's 65.38 grams per mole for zinc. However, when we are doing mass volume problems, remember the magic number, 22.4 liters per mole, or of whatever substance it is that we're looking for, that's the gas in this scenario, is the hydrogen. So we're looking for hydrogen gas. It's 22.4 liters per mole. That's very helpful. So we go over here to the balanced equation. We know zinc is combining with hydrochloric acid to yield zinc chloride and hydrogen gas. That's neutralized. We now need to balance it. So we balance it simply by putting a 2 here, which means now we have 1 zinc on each side, 2 hydrogen and 2 chlorine. As you see, there's 2 there. So it is balanced. If this was a teeter-totter, everything on this side, according to the law of conservation of mass, would equal everything on this side. And it does. So that's our scenario. So what are we looking for, though? This is our known, and our unknown is here. Notice, yeah, there's a 2 there, but that's only 1 mole of hydrogen. No numbers here, and that's 1 mole of zinc. So we're at a 1-to-1 ratio for our next step. Our next step normally would go here, but since I have a space, I'll do it right here. So we set up our boxes. In here, we're going to put our what is our known. So we got 15 grams of zinc. Okay, you put your known there. Our logical pathway is this. We're going to go from mass of zinc to moles of zinc to moles of hydrogen to volume hydrogen. Okay, that's the pathway we're going to be taking to get to what we need to do. So from 15 grams of zinc, I need to get the moles of zinc. So looking up here, I already know that 65.38 grams is equal to 1 mole. So I go 65.38 grams of zinc is equal to 1 mole of zinc. So now I've gone from mass of zinc to moles of zinc. That's our pathway. Now we need to get the moles of hydrogen. So we do that by using our molar ratio. You put the unknown on top. I have 1 mole from here, 1 mole of hydrogen, even though there's a 2 there, it's a diatomic molecule. 1 mole of hydrogen is to 1 mole of zinc. Okay? And then the magic number up here, so look at, we've gone from mass of zinc to moles of hydrogen, notice. And now we have 22.4 liters of hydrogen is equal to 1 mole of hydrogen. Okay, so we now can eliminate any units that we don't need that are duplicates, like this: grams of zinc, moles of zinc, moles of zinc, moles of hydrogen, moles of hydrogen. And we have 15 times 1 times 1 times 22.4 on top, divided by 65. So over here on the calculator, watch this. We take 15 times 22.4 equals 336. So over here, 336, that's that across the top, divided by the 65.38. Okay? So everything on top multiplied, everything on the bottom multiplied, the top divided by the bottom, and 336 divided by 65.38 equals 5.139. So 5.14, we're going to round it up, and that's, notice the ending unit there, liters of hydrogen gas. Thank you so much. That's how you solve a mass volume problem.